Hi, this is Sang Kim. I'm with Ty Pennington, freshman baseball player at Northern Valley Regional High School. And today I'd like to show you how to go through the preparation and setup for a 5-sensor torso lead arm system. So the first thing we're going to do is pick the configuration that we want. So we'll go with the torso lead arm bat configuration. And then we're going to take, so that's 5 sensors. So we're going to take our system and turn on 5 sensors. Then we're going to hit the connect button. And at this point, the system is making a connection to the 5 sensors. And we're all set. So at this point, you can hit the next, and we are going to put on the straps and sensors. So over here, I'm doing them kind of strap sensor, but you can also just put on all the straps and then go through the process. But here we are putting on a chest harness. So these are new. Most of you probably have a chest strap, but we had just received these. They're more secure, and the chest sensor will go on the back. And these are available on our website. So that strap's on, the diagram's indicating to put the sensor. Now, if you're putting it on the back, you want to put it with the white side in and the blue side facing out. So most of the time, the white side of the sensor is facing out, but if you're putting it on the back, put it white side in. So we hit next, and now we're going to put on the hip sensor. So you can either use the clip mount provided, or in this case, I'm just taking the long strap and I'm putting the sensor on the hip as a belt. Now, again, that was white side out. Now we're moving to the upper arm. So putting on that strap, I like to put that a little bit above the elbow on the side of the bicep so we don't get muscle interference from the bicep. Again, the sensor should be put in white side out. Okay, now we're moving on to the wrist, or really the forearm, just above, a little higher than where you would place a watch. We don't want it to interfere with the glove. And again, white side out, placing that in. Okay, then we're going to hit the next button again. And the last is the bat sensor. Now, I already have the bat mount placed on here. It's important that the triangle is facing, the point of the triangle is facing the tip of the bat, and the LED portion of that sensor is also facing the tip of the bat. I want to put that just above the hands. We don't need to calibrate the bat, so I'm just setting that aside. Now, the calibration pose is one of the most important things to an accurate capture. So we want the person standing in the attention pose, just like the diagram seen. We don't want the arms flared out, no bend in the elbows, wrists, and they just need to hold that position between the 2 beeps. Okay, straight back, straight legs, no bend in knees, arms not flared out, tight against the sides. Now at this point, we're just setting the recording options. So we're going to start off with just a basic single capture. So you can set the countdown time, the total record time. Auto download is on, which means it'll download immediately, and auto splitting is off. Okay, and you just hit the capture, wait for the beep, and then you swing. Okay. Now at this point, the sensors have recorded the movement and are downloading them to your device. And what we want to do at this point is put as much information about the swing as possible, so that when you go back and look at it later, not only when you know who the player was and the date, but you know anything about the type of contact, the direction, the height. And also in the comments section, you could put, again, any additional information. Like in this case, it was just a practice swing. It wasn't a tee, a soft toss, or a fast toss. At this point, it's downloaded. You just hit the see visualization, and you could review the swing with the player. And you can go through all of the graphs, metrics, etc. And I'll go into that part later. Now at this point, what I'd like to show you is how to do a multi-capture swing. So this would be ideal if you're doing like batting practice and you throw multiple pitches. You want to set a longer recording time, so it could be like 20, 30, 40 seconds. And you also want to set the um, auto split on. And what this is going to do is allow you to just continuously record for however much time that you had, and the system will automatically detect each swing and split them up for you. Now, if it's a longer capture such as this, it will take a little bit longer to download because there'll be more data there. But when the process is finished, you will see, in this case, I think he took 3 swings. You will see the system will show 3 individual swings and their metrics, even though it was one continuous capture. So finally, in this tutorial, I'd like to show you some of the ways that we can use the system to analyze the hitting. And for this, I will go into the swing bank, which is the second icon that looks like a book on the bottom. And we'll take a look at the one on the bottom that says FSP and spine plane matches up. So one of the first things I look at is the kinematic sequence in the graphs to make sure they're efficiently transferring their energy from the ground to the bat. So to do that, I click on the graphs icon, which is the top one on the right, and kinematic sequence is on the top. Now, there's a lot to know about the kinematic sequence, but just give kind of a quick tutorial. So what we're doing here is measuring the angular velocity of the pelvis, chest, lead arm, and bat. Typically are not too interested in the lead forearm. And some of the things that we're looking for are in the beginning, and by the way, you could move and zoom just using your fingers like you would on a map, and kind of go segment by segment. So over here, some of the things that we're looking at are, we're looking for the pelvis, which is the red line, to cross the horizontal 0 line first. So that when it's below the 0 line, it means that they're counter-rotating or rotating away from the target. And when that red line crosses, the hips are actually rotating towards. And the green line, which is the chest, is when it crosses, it's changing as well. And sometimes it's easier to see from the top view, and you can go to Tools and turn on the hip line, shoulder line, and hip line. And you could see how the hips are turning right there, it's transitioning, and the chest right there. And you could see that the hips are rotating, accelerating before the chest, and that generates some load in the spine. So that's actually a pretty nice pattern. Then when we add the lead arm to the equation, you could see that the lead arm is actually speeding up before the chest. So what we'd like to see is the more distal body parts speeding up, increasing velocity after the more proximal body parts. So in this case, I'd rather see the blue line increasing after the green line. So if this is a player I was working with, his hip-chest sequence is good, but his chest-arm sequence is off. Arms increasing velocity before the chest. So that would be something to work on. And then if we look at the arm and bat, the bat is accelerating after the arm. So he's not casting. So of the 3, pelvis chest is good. And the lead arm bat is good, but the lead arm is accelerating before the chest. Okay, so that would just be, again, there's a lot more you can go into in a kinematic sequence graph, but that's just one thing you could work on right away. And if you're doing that for the sake of speed, you can just pick chest, lead, upper arm configuration, just 2 sensors. It'll capture faster, it'll download faster, and you could just work on that. Don't even need the hips, forearm, or bat. Okay. Now, again, if you look at all the graphs, there's a lot of analysis that you could do here depending on what you want to work on, but I just want to
show you one of the things that we start with. Already showed you the hip chest from the tools, but let me show you a couple more things. So one of the other things from a bat plane perspective is we could turn on the functional swing plane, which is on the top right, and the spine plane. Oops. And what we're looking for here is if you take the swing to the impact, you want those two things to line up. Now if they do, that means the swing plane is at a 90-degree angle to the shoulder line. Okay? Now if you believe that's an efficient way to swing, you could see that. So you could see this player, it's really well in line. The other thing that we look at from the green swing plane, which is the actual, versus the red, which is the ideal, is you want to see that going through the chest area. Okay, sometimes if the swing is too steep or the angle of the plane is not ideal, that plane might, cross his body more towards the belt or way above his head. So those are a couple of quick things you can look at. The other way to do it is you can simply click on the More button and hit the metrics. And what this will give you is, rather than having to go into each graph and kind of identifying everything, this pulls out all of the relevant information and gives you in a quick table. So you can quickly see the sequence. So his transition sequence was good, hip, chest, arm, bat, but his deceleration sequence was off, hip, arm, chest, bat. So as we saw earlier, the arm's a little bit early in the acceleration deceleration phase. You can also see the gains from each segment. So typically we want to see at least a 30 or 40% gain from pelvis to the chest. In this case, it was only 21%. The speed gain from chest to arm was 33%, which is okay. And from the arm to the bat, we're looking for at least 100%. So again, pretty good here. One of the other key things that we look at is the spine stability. So and at any point you can see the question marks next to each of these for a more detailed explanation. But the spine stability measures from the point of hip transition how stable the spine is in rotation through impact. Okay, so 82 is a little on the low side. In the better professional players, we're seeing numbers in the mid-90s. The next one, which is the third one down from the bottom, is the bat attack angle. So this is the vertical angle of the bat through the hitting zone. So 14 degrees is kind of right in the sweet spot. If we know the ball is traveling on a downward trajectory, say between 6 and 14 or 8 and 12, depending on the type of pitch, you want the bat traveling on an upward directory to match that. We don't want to see a negative number, which would mean the bat is in a descending path, or a very high number, then the bat will not be traveling in the same plane as the ball coming down. We also give lots of other numbers here: rotational speeds, acceleration, some quickness measures, and you can click on the question marks to see any one of these.
So finally, we'll show you how to compare two swings. So first, click the More button on the bottom right with the 3 dots. Then click Compare. And then you have a few options. You could choose from your own swings, pro swings, or other students' swings. So for this case, let's pick the Pro Swings tab, and we'll pick a swing. Now, because we have the bat, we can synchronize them by their positions. So you can hit the double arrows to step through the swings in various positions. We can also look at them from different angles. And you can use the controls on the upper left to change the perspectives. We can even compare the graphs of both swings. And finally, we can use any of the visual tools. So for example, the bat path.